So there has been other videos made, 4 videos on this 2019 practice midterm, but of course on those other videos I only explain a couple of questions, and there's several questions that are missing. So I want to just do a supplementary video to those videos on those that we did not explain, like number 3 and number 4. This is an absolute value equation, and the first step to solving any absolute value equation is to isolate the absolute value. So you would subtract 8, and you'd end up with 2 absolute value x minus 4 equals -2. After that, you divide by 2 to get that absolute value by itself, and we end up with the absolute value of x minus 4 equals -1. And I did see a lot of students continue to do the positive and the negative situation, right? Where the positive situation, you write it exactly the way it is without the absolute values, and the negative situation, you do the same thing, write it without the absolute values, change the right side of the sign, and then solve both and get those answers. However, that's a waste of time. Why is that a waste of time? Because whenever you end up with an absolute value equaling a negative number, you could just stop right there and say no solution. No solution. Okay? You don't have to do the positive and negative situation. Now, it'd be a different story if you had -1x, right? Or -1, any variable. If you have a variable, then yeah, you need to continue with the positive and negative situation. But if it's simply an absolute value equaling a negative number, that is impossible. So that's why it's no solution. Just wanted to explain that one. That was not explained on the previous videos. This one, might as well do it. It was not explained on previous videos. Again, you want to isolate the absolute value first. You want to get this absolute value by itself. It's kind of like if you had the equation -4x plus 17 equals 5. You'd get rid of the 17 first. So let's get rid of that 17 by subtracting 17 on both sides. We now have -4, absolute value of 2x minus 9, close absolute value equals -12. And we still need to get rid of that -4 that's being multiplied in front of the absolute value. Now some people might think, oh, you could just say no solution. No, you can't say no solution, because even though that's a -12 over there, watch what happens when I divide both sides by -4. You will end up with 2x minus 9 equaling +3. So we are back to a positive number, so we must continue on. This is where you do the positive situation and the negative situation. I usually put a squiggly line between it. And again, the positive situation is just rewriting it without these absolute value symbols, exactly the way it is. So we have a 2x minus 9 equals 3. And on the negative situation, same exact thing, no absolute values, 2x minus 9 equals 3. But that 3, you have to change the sign. Whatever's on the right side, you have to change the sign. So even if you had like an x minus 3, then you would have to change the x to a -x, and that -3 to a +3. So if you have a binomial, you have to change all the signs. Right here, it's just the number 3, and on the negative situation, you change it to a -3. Anyway, we need to solve both of those. So let's add 9 here, add 9 there. We end up with 2x equaling, what is that, 12. And then we divide by 2 to get rid of that multiplication of 2. We end up with x equals 6. That's one answer. And then we go back to the other one and solve that one. We add 9, 2x equals 6. And divide by 2, x equals 3 is your other answer. Now, technically, it would be a good idea to plug in your 6 right there. 2 times 6 is 12. 12 take away 9 is 3. -4 times the absolute value of 3, that's -4 times 3, that's -12. -12 plus 17 really is 5. You double checked it. You know for sure that this is a correct answer. 3, you plug it in as well. 2 times 3 is 6. 6 minus 9 is -3. -4 times the absolute value of -3, that's -4 times 3, which is 12. -12 again. -12 plus 17 again is 5. Both of these answers work, so we're absolutely positive that this is correct. Both answers work. You have to include both answers. If you only write one answer, you only, well, technically you don't have it right. You only have half of it right. The other video I did explain number 5. I did explain 7 and 8. I skipped number 6. So let's do number 6 since it was pretty interesting. I saw some students struggle with that. We're going to solve this inequality, and solving an inequality is exactly like solving an equation. The only difference is on the last step, if you multiply or divide by a negative, you must flip the inequality symbol. So step 1 to solving any equation is to simplify it, which means distributive property and combining like terms. So I have a negative 6x, I have a positive 3 when I distribute that multiplication of negative 3. Then I bring down the 6. So I have distributed. After that, I have 3 terms on the right side of this inequality. I could now combine like terms. I could combine this positive 3 with this positive 6, rewriting negative 6x plus 9, because 3 plus 6 is 9. The inequality, the less than or equal to, just comes down. Less than or equal to, the negative 12 just comes down, okay? So we need to decide something right here, guys. Do we want to get the x by itself on the left side or the right side, or the right side? Shouldn't have said right. But anyway, it's up to you guys. Do you want to get the x on the left side or on the right side by itself? Left side. Okay, so it is on the right side, right? So some of us would say, let's get it by itself on the right side. It'll actually be slightly quicker, but then again, slightly more confusing. So I always like to move the x to the left, even though it takes more steps. But for the sake of looking at the confusing situation and trying to make it not confusing, let's isolate it on this side. Okay, it doesn't matter which way you go, you should still get the same answer. So let's say I did want to get the x by itself on the right side. Let's get that 9 out of there by subtracting 9. Subtracting 9, we will have negative 21 is less than or equal to negative 6x. And you know what? To make it less confusing, since I'm running out of space, I am going to rewrite this exact inequality over here. Negative 21 is less than or equal to negative 6x. Now, I still need to get this x by itself on the right side. So I would have to divide by negative 6, and that's what I'm going to do. I'm going to divide by negative 6. I'm going to divide by negative 6. Now, technically, this is my last step. I am dividing by a negative. So this eliminates. The x comes down, and since I divided by a negative on my last step, what must I do with this inequality? You flip it, right? So I need to change it to this. Okay, so it was opening to the right, now it's going to open to the left. That's what happens when you divide by a negative on your last step. Now, a negative divided by a negative, right here, that becomes positive. And it would be nice if it were 21 divided by 7, but it's not. It's 21 divided by 6, which doesn't work nicely. But whenever you have a fraction, at least if you can't divide it, at least try to reduce it. And we could reduce by 3. So let's reduce by 3, and we will end up with a reduced fraction. 21 divided by 3 is 7. 6 divided by 3 is 2. So that is 7 halves. Now this is technically our answer, but whenever we write an answer of an inequality, you want to have the x on the left side. Right? Because right here, it's like if you're talking about 7 halves. 7 halves is greater than or equal to x. But we really want to be talking about x. So I'm going to take this answer right here, and I'm going to flip everything. I want to move the x to the left side. I want to move the 7 halves to the right side. And this was our answer. It's true. This is the correct answer. It's opening up to the 7 halves. So it needs to continue opening up to the 7 halves. Okay? So it's going to flip again in a sense. This is your final answer, okay? X is less than or equal to 7 halves. Now, some students got really confused because it started off as a less than or equal to, less than or equal to, less than or equal to, and then it flipped again. But it's just that we've got the x on the right side instead of the x on the left side. If at this point, instead of moving the 9 over there, if I would have added 6x and added 6x, and then added 12 and added 12, and I would have gotten the x to the left at the beginning, that would have made it slightly more understandable. But I hope you guys understand now that I've explained it. 9 and 10 were not explained on the previous videos as well. These are compound inequalities. Sometimes, yes, they're written together with the x in the middle, and you got to isolate that x. Sometimes they're written separately, but with the word or. And technically, when you have this or situation, you should think of number lines, okay? So let's do number 9. What would I need to do to get x by itself in the middle? Anybody? Add 6 is absolutely right. Add 6, that would get rid of the minus 6 in the middle. And what you do to the middle, you do to both outside sides. So you add 6 here and add 6 over there. You will have 2x. The inequalities come down. Negative 18 plus 6, that is negative 12. And we have 8 plus 6, which is 14. Final step here would be to divide by 2, divide by 2, divide by 2. Do I need to flip the inequalities? No, because I did not divide by a negative on my last step. So we have a negative 6, we have the x in the middle, we have 7 over here, less than or equal to symbols. Okay? This is your answer. Moving on. Do you guys want to see number 10? Sure? Okay. So number 10, distribute, like again, we're going to pretend that, let's just look at one of them at a time, okay? So if you just had this one simple inequality, how would you solve that? Well, you would distribute first. So you'd end up with 18x minus 12 is less than 60. Then you want to get 8x by itself, so you would add 12. Add 12, you end up with 18x is less than 72. Final step would be to get rid of that 18 that's being multiplied with x. So you're going to divide by 18, and I believe the answer is 4, right? So, of course, you could use a calculator. X, you do not flip the inequality because you did not divide by negative 18. You divide by 18. That is 4. Now that we've done that first inequality, now we could look at the other inequality, okay? And let's solve that other inequality. We don't have to distribute on this one, but we do have a variable on both sides of the inequality. We don't want x's on both sides. We only want it on one side. So if it's an inequality for sure, get the x's to the left. We already talked about that. It's a lot easier when x's are to the left. So I would go with that. Let's subtract 6x, subtract 6x. We will have 2x because 8 take away 6 is 2. Bring down that minus 6, bring down the inequality, bring down 12. Let's get the x by itself on the left side. I'm going to get rid of that minus 6 by adding 6 here and adding 6 there. I have 2x is greater than 18. And then for my last step, divide by 2, divide by 2. I don't flip an inequality because I did not divide by a negative. My answer is x is greater than 9. So how do we write our answer? We're supposed to write this answer with this answer written together with the word or, okay? Now, what this is implying is that visually the areas are apart from each other. And let's just verify that real quick. If we go to a number line and we put the smaller number on the left side, the bigger number on the right side, and we think about x is less than 4, x is less than 4 is to the left, and then we think about x is greater than 9, x is greater than 9 is to the right. So we have demonstrated that the areas are going apart with the word or, okay? I believe on the midterm, not only will you be asked to solve a couple of these, but you're also going to have to graph them on a number line, okay? So we have an absolute value inequality, and these are very, very fun. Why? Because step 1 is to isolate the absolute value. So I need to get rid of this minus 20 by adding 20. Now that it's isolated, now that the absolute value is all by itself, now I could worry about the positive situation and the negative situation with a squiggly line in between. Again, the positive situation would be writing it exactly the way it is. 4x plus 4 is less than or equal to 16 without the absolute values. The negative situation, same exact thing, 4x plus 4, but you have to not only change that 16 to a negative, but you also have to change that less than or equal to a greater than or equal to. Okay, so for the negative situation, just emphasize this, for the negative situation, we changed the sign and changed the symbol, flip the symbol and change the sign of whatever was on the right side. So keep that in mind. Now let's solve both. So you will have minus 4, minus 4. Oh, I didn't use a different color. Sorry. 4x is less than or equal to 12. Final step would be to divide by 4, divide by 4. X is less than or equal to 3. Okay, so that's one answer, one possible answer. And we just need to do the other one. Let's subtract 4, subtract 4. We will end up with 4x is greater than or equal to negative 20. Final step is to divide by 4, divide by 4. So we have x is greater than or equal to negative 5. And I did not flip the inequality because I did not divide by a negative. Now, these are inequalities, not an absolute value equation. If I had an equation, if it were an equal sign, I'd get these answers and that would be it. I would say x is equal to 3, x is equal to negative 5. But it's an inequality, so I must think of what they look like visually on a number line, okay? So if I go to a number line and I put the smaller number, in this case negative 5, on the left side, the bigger number 3 on the right side, and then I actually think about graphing this guy, x is less than or equal to 3, that's a solid dot at 3 to the left because it's less than. And then I think about graphing this guy, x is greater than or equal to negative 5, solid dot on the negative 5, greater than to the right. What we have here is an area that's together, right? We have an area from this negative 5 to the positive 3. It's an area that's together. So because the areas are together, these two answers have to be written together as a compound inequality, okay? So how am I going to write that together as a compound inequality? It's pretty easy. The smaller number on your number line is already on the left side. The bigger number is already on the right side. All you do is put the x in the middle, put less than symbols, right? That's because if you put the smaller number on the left and the bigger number on the right, obviously it has to open up to the right side if the bigger number is on the right side. So this is always going to be true, less than symbols. Don't forget, these were or equal to's on the original, so I do need solid lines underneath those inequalities there. So there's my final complete answer. If you don't write it, if you leave it like this separate, I cannot give you full credit on the midterm, okay? So please make sure that you graph it to see if you're going to write it together. Now, if these areas would have been apart, you would have written both of these with the word or between them. But because the areas are together, you have to write it together as a compound inequality with the x in the middle, smaller number on the left, bigger number on the right, and that's how you do it. Okay, so let's move on. Now, on the back side of the first page, on the other videos, on the older videos, I did explain number 13, and 14 through 17 are the same exact thing, which is really easy. I don't feel that it's necessary, but I'll do another if you want. Which one do you want to see? 14 through 17, which one? No. They're too easy to do all of them. Pick one. 17. All right, so it says, actually 17 is the only one that's slightly different, okay? So 16, find the average rate of change. Average rate of change means slope. And it says from minute 5 to minute 8. So for 16, let's do 16, it says minute 5 and minute 8. Okay, so where is minute 5 at? It's at 5 on the x and more than 9, but not halfway. So it's about 10 because it's going 9 to 12, 9, 10, 11, 12. So this is about 10. So you would first say that you have your first coordinate at 5, 10, and the second coordinate at 8, 6, because that's obviously at 6, right? So 5, 10, and 8, 6. And once you have those two coordinates down, of course, you're going to be using the slope formula, which is y2 minus y1 over x2 minus x1. And when we use the formula, it's good to do the division and the subtraction signs and then plug in your y2 value of 6, your y1 value of 10, your x2 value of 8, and your x1 value of 5. So 6 minus 10, that's negative 4. 8 minus 5, that's 3. There's your rate of change. That's your slope. Okay? Ridiculously easy. Keep in mind that if you end up with a 0 underneath, that's undefined. If you end up with a 0 up on top, the answer is 0. Now, the last one, it says, which 2 minutes would you select for a line that best fits in this data? And the truth is the answers may vary, but if you take a line, So I have my red line right here, and if I pick like the first point and maybe the second to the last point, like minute 1 and minute 8, that'd be a decent line that best fits. But that's not like, I mean, if you might have thought, well, maybe if I picked minute 3 and minute 9, that would also be decent. But I think the first minute and 8 minute, or minute 9 would be better. So it varies, but you want to get 2 points that are pretty much making a line that have like an equal amount of dots up on top and on the bottom, the one that best fits, obviously. All right. So if there is one on the test, it'll be more obvious than this one. Okay. Like maybe in this case, you could have also said minute 2 and minute 9. That'd be pretty good. Minute 2 and minute 9. That's arguably just as good as minute 1 and minute 9, I think. So, yeah, as long as like you're not picking like minutes 2 and 3, that would be horrible, or minutes 1 and 4, that would be horrible, right? Or minutes 1 and 2, same line. So you want to pick 2 points that kind of give you the line that best fits, obviously. So on the other video I explained, or on the previous videos I explained number 20. It might be a good idea to do 21 here. We're going to use this data up here with the relation, or explaining the relationship between the time of a workout and the calories burned. Obviously, the more time that you work out, the more calories that you burn, right? So it says use a prediction equation before rounding the predicted missing value. Okay, so we need to get a prediction equation, and they're going to tell you specifically which coordinates to use, which points to use. They want you to use the first and the third on number 21. So here's the first one, and here's the third one. So what we need to do is begin by jotting down those 2 coordinates. So we have the 2 coordinates here, 17, 133, and 39, and 381. So again, we're going to begin by doing the slope formula. M equals y2 minus y1 over x2 minus x1. So y2 is 381. Y1 is 133. X2 is 39. X1 is 17. And we're going to do some math. Calculator will help. What's 381 take away 133? So we end up with 248 up on top, and 39 take away 17, 22? And what is, with the calculator, 248 divided by 22? 11.27? Is that exact, or is that an approximation? 11, what does it exactly say on the calculator? 2727, and it repeats. Okay, so yeah, right here I would definitely just go with the tenths and hundredths position. So 11.27, this 2 does not change that 7 to an 8. So we're going to go with M is about 11.27. So we have a slope as a decimal, and we have some points that we used to get this slope. So obviously we're going to go with a point slope form equation. So let's do that. So there's our point slope form equation, and we're going to be using the slope of 11.27, and we're going to be using this first point. The y1 is 133 and the x1 is 17. So I recommend rewriting it with blank spots. Y minus blank spot equals blank spot, parenthesis x minus blank spot. The y1 is 133. The m is 11.27. The x1 is 17. So this is our point slope form equation, but they want the prediction equation in slope intercept. So we're definitely going to have to rely on calculators here. We're going to distribute to get rid of the parentheses. We're going to take 11.27 and multiply it by x. That'll be 11.27x. And then 11.27 times a negative 17. Can somebody help me out with that with the calculator? 191. So we're going to 191.59. Okay. There was no other numbers over here? No? Okay, cool. So we still have the y minus 133 in front. So we need to get rid of that minus 133 by adding 133. And what you do to one side, you do to the other side, add 133. So last thing to ask on a calculator, what is 133 take away 191.59? Or you could do negative 191.59 plus 133. And that will give us our final prediction equation. Y equals 11.27x, and anybody have that answer? Negative 191.59 plus 133? It's negative what? Negative 58.59. You guys agree with that? Yes? Okay. So there is our prediction equation. This is one answer that you will have to write exactly like this on the midterm. And then the other answer, so I think this is question number 7 on the midterm. There will also be a 7b. 7a will be for you to write the prediction equation. 7b will be for you to find that missing value. So if you go back to the chart, the missing value is right here. You want to know if you were to plug in 60 into your prediction equation, what would your output be? So that's what we need to do still for the second half of this question, which will be number 7 on the midterm, I believe. So let's plug in y equals 11.27, but instead of x, we're plugging in the input 60 minus 58.59. So could somebody do me a favor and multiply on the calculator 11.27 times 60? Say again?
676.2.
All right, cool. And how about take away 58.59 on the calculator? 617.61. Yeah? Cool. So this would be the other part of your answer. The input 60 gave us the output 617.61 using our prediction equation. So obviously you got to be careful with this prediction equation, because if you don't get the prediction equation right, then you're not going to get the second part right. That will be on the midterm for sure. So again, this video is already getting way too long, but here's one that I did not explain on previous ones. The way I would tackle piecewise functions is to look at the line. Obviously, you need an m and you need a b. M is slope from left to right. What's happening? It's going down 1 over 1. Or even if you went from here, down 2 over 2. So the slope is negative 1. So far, your equation is y equals negative 1 over 1. You could just leave it as negative x. And you need a b value. Where would this cross the y-axis? If you go down 1 over 1, it would cross at negative 3. Okay? So my equation is y equals negative x minus 3. Does everybody understand that? Okay, I hope so. Now, if you look at the green line, right? The green line, it's going to be y equals mx plus b as well. What is the m? You're going up 1, 2 over 1. So you really have y equals 2x. You could put 2 over 1x, but 2x is better. And what is the b value? Obviously, this would cross the y-axis. It does touch at 1. It would cross if it continued. And the last one, it's going down 1 over 1. No, down 1 over, nope, down 2 over 1, 2, 3. Okay, so you got to pick nice points. This first one and this last one. So down 2, so that's y equals down 2 over 3. That's negative 2/3 with an x, and it does cross the y-axis at negative 1. So those are my 3 equations. That's what I would do if I were you as you're looking at a piecewise function, right? Just pretend that you're looking at single lines, right? We got the equation of the blue line, got the equation of the green line, got the equation of the red line, and now we could write our entire piecewise function, f of x equals big giant brackets. We're going to begin from left to right. What do we see from left to right first? That blue one. It says y equals negative x minus 3. Here's the y equals. All we're going to write is a negative x minus 3. Now, of course, it needs a condition, and we're talking about x values only. That's a condition, which is kind of like the domain of this blue one only. So we're going to say if your x values are less than or equal to negative 1. If you're thinking, what the heck, where did he get that from? Well, it's a solid dot at the x value of -1. And the entire blue ray exists at -1 and to the left. Yes, it's going up, but who cares about up or down? Domain conditions is all about x's. So it's at -1 and to the left. So how do you say at -1 and to the left? That's x is less than or equal to -1. The green one is between two areas, but then again, let's start with the equation y equals 2x plus 1. Here's the y equals. We're just going to write the 2x plus 1 in the middle. Now the condition if, and this is between two x values. The green line doesn't go to the left forever, it doesn't go to the right forever. It's between this x value, this dot, and this dot. This x value is -1, this x value is 0. So it's between -1 and 0. So we're going to put the x in between the -1 and the 0. And of course, whenever you do that, you put the smaller number on the left, bigger number on the right. You put less than symbols because it has to open up to the right, both symbols. Anyway, the one on the left, the -1 is an open dot, so you don't need a solid line. But the one on the right at 0 is a solid dot, so you need a solid line underneath that inequality. Time for our last one. Instead of y equals -2/3 x minus 1, here's the y equals. All we need to do is write the -2/3 x minus 1. And then the condition if, where's this red ray at? Well, it's starting at the x value of 0 going to the right. So we would say if x is greater than to the right, 0. And it's not a solid dot, so do not put a solid line underneath it. There's your piecewise function. That's how you do it. Now, number 27, state the domain and the range of the above piecewise function. Domain is the x's. Do any of these three pieces go to the left forever? Yes, the blue one does. Does any of these three pieces go to the right forever? Yes, the red one does. So it does go to the left and to the right forever. That means that your domain is x equals all real numbers. How about the range? The range are your y values. Does this go up forever or does it have a maximum point? Some people might see this and think, oh, y is less than or equal to 1. That's not true because this blue line goes up forever. This red line goes down forever. So the range would also be y equals all real numbers. I hope that makes sense. This is too easy. Describing translations, those are just shifts. I explained that in the previous video. This one would just be that it shifts 3 units to the left. The parabola shifts 3 units to the left. This would be that the absolute value function, the v, from the parent graph to this one shifts 9 units down. Let's get to something that's a little more entertaining, either 35 or 36. 36, sure, why not? Okay, so whenever and by the way, the instructions here say describe the transformations from the original parent graph to this new R of x graph. So we know that the original parent graph is a V and it has the vertex at 0, 0. It's opening up and it has an a value of 1. Now, the first thing that we see here is a negative sign. That negative sign means that it reflects over the x-axis. And I would like you to number it. Number 1, the first transformation, that negative sign means that it reflects over the x-axis. So it used to open up, now it's opening down. Then after that, you look at the actual number value, right? The negative means that it reflects over the x-axis, opening down. But now what do we have here? Do we have a fraction that's closer to 0? Or do we have a number that's greater than 1 further away from 0? This is a 3, which is further away from 0, greater than 1. This is going to be a vertical stretch. So let's all write that down. Second thing is a vertical stretch by a factor of 3. And last but not least, we see the h and the k, which tell us our third transformation. You could also call it the final translation, which is a shift. And we would say it shifts 2 units to the what? To the left, because you have to think opposite of what you see on h. And it also shifts 1 unit where? Down. Because you take k for what it is. There are the detailed 3 steps of the entire transformations from the original parent graph to this new R of x graph. And you will have to write it out exactly like this. There's no multiple choice. You actually have to write it out. If you don't say if you just say reflects and you don't put over the x-axis, then I can't give you full credit. So you have to write reflects over the x-axis. If you just say stretch, I mean, I want you to write vertical stretch, right? And if you just say vertical stretch and you don't say how it gets vertically stretched by a factor of 3, I need at least vertical stretch at least by 3. Okay, if you forget the word factor, okay, whatever. But I need to know whether it's a stretch or compression, and I need to know how it got stretched or compressed, in this case by 3. Any questions? Yes?
Can you explain again how you know it's a vertical?
If it's a negative, it reflects over the x-axis.
If it's a negative?
If it's a negative, it reflects over the x-axis. Now, on number 35, my first transformation is not going to be reflects over the x-axis. Why not? Because it's just a regular 2. So it doesn't reflect over the x-axis. I don't mention that. So what do I mention? What's the first thing I mention? I got to mention this. And what is this? Vertical stretch again. Yeah, when is it a compression? Think about this. If you multiply any number by 2, is it going to shrink? Is it going to get smashed? Or is it going to grow? It's going to grow. 2 times 10 is 20, right? But if this were a fraction less than 1, what would happen to 10? Like, what's 10 times half? That becomes 5. It gets smashed. It gets smaller. Make sense? So if your a value is greater than 1, it's going to cause it to stretch, to get taller, to grow in a sense. If it's a value that's a fraction that's less than 1, closer to 0, it gets smashed. It gets smaller, right?
Why is -3?
The negative just has to do with the reflection. So this just means reflects. This is a vertical stretch. Now, if I would have had -1/2, then it'd be a reflection and then a vertical compression of 1/2. Right here, there is no reflection, so you just go to 2. That's a vertical stretch. And you have to write at least by 2, okay? And then the other 2 transformations would be shifts 2 units to right and 5 down. See number 34? That one's explained on the previous video. It reflects and then it gets vertically compressed by 1/3 and then it shifts 2 to the left and 4 down. That's it for transformations. If we move on to the last section, we're going to stop on number 38, and I did explain 37 on a previous video. We want to graph this inequality. Let's graph it. Let's begin by stating our vertex HK. That'd be a -2, 3. So if you go to -2 and 3, you're right here. And yes, you could draw your axis symmetry through it if you want. You don't have to. But the a value is, this particular a value is the only time you could actually treat it like an actual slope of going down 1 over 3 from that vertex. So down 1 over 1, 2, 3, you put a dot right there. Then you continue to go down 1 over 1, 2, 3, put a dot right there. Then you could do the same in the other direction. And before you draw your very wide, your vertically compressed V, before you do that, you've got to ask yourself, is this a solid graph or is it a dotted graph? What do you say? Solid, because there's a solid line underneath that inequality. So we're going to make this a solid V. See, I'm not doing a dotted line or anything. It's just a solid V going right through those dots. And now we need a shade. Do we shade above what we see or below what we see? If you go to any point on here, like this blue dot, do I shade up here or do I shade down here? Above, because it's a greater than or equal to. So you're going to shade above, up there, up there. So you just pretty much shade everything up here on this side of the graph. And that's it, guys. I hope this helps. You guys need to be ready for the midterm.